Good morning, everyone. Hope everything's going well. We're on 33-1 today. You can find this on page 501. Just a quick reminder that our fluency test on this will be next week, next Tuesday. So there's going to be a little bit extra practice tonight. There is no review packet or anything, just like the last fluency test. But if you've been doing all the homework, go back and review it and do tonight's homework. You should be good to go. So what I thought we'd do is start with this problem here. This is a good practice problem from Tuesday, just reviewing how to find the sine, cosine, and tangent of some angles. The first one's in degrees, and the second one is in radians. So go ahead and pause it, pause the video, and try these two problems, and then I'll explain here in the next slide. Okay, so here's what you should have had. Zoom out here a little bit. So for this first one, negative 300, the first step is to find where this angle terminates, right? So negative angles go in a clockwise direction, and negative 300 terminates right here. Oh, I don't want to do that. Terminates here in quadrant 1, right? So that means the reference angle then is 60 degrees. In order to make these triangles, and which allow us to find the sine and the cosine and ratios, we need to know which quadrant it is, and we need to know the reference angle. So this triangle down here in quadrant 1, I just redrew it over here so we could see it better. Okay, so we're using what we learned about 30, 60, 90 triangles, and remember the radius is always 1, so that side there, the hypotenuse is 1. I know those are the ratios, and those ratios allow me to get the xy value of this point right there. That is the point that the terminating side hits. Once you have that xy value of those points, the sine corresponds to the y value. Now remember, sine is really y over the y value over the hypotenuse, but because we're on the unit circle, the hypotenuse is always 1. The cosine value is a half, that's the x value, and then the tangent value is the y over x. So that's what I did right down here. I divided some fractions, multiplied by the reciprocal and all that stuff, and I got positive root 3. That's it. For the second one, radian angles. 5 pi over 4 is a little bit past pi, because pi would be 4 pi over 4. So then I knew it was down here in quadrant 3. Once I had that angle, I found the reference angle. Now, the sooner you can get good at using radian angles, the better, right? If you're still converting to degrees, that's not the end of the world. It's just going to take more time. You do have to understand radians and get more comfortable with them. So once I have this little blue angle here being pi over 4, I know pi over 4 is the same as 45. So that's the angle right there, 45 degrees or pi over 4. That's my special right triangle. Now remember, you can have positive and negative xy values. This red point right here is just a point. That would be a negative x and a negative y, making my sine and cosine ratios both negative. The tangent value for this one I think is easy, because negative root 2 over 2 divided by negative root 2 over 2 is just 1. Anytime you divide the same number, it's going to be either 1 or negative 1, depending on the signs. Okay, so that is a good review from Tuesday. And just remember this visual guide we have. This is the unit circle. All the unit circle is a nice reference. It has all of these triangles, right? Here's the first triangle we dealt with. That's the 30, 60, 90 right triangle. Then it also has the coordinates of that 45, 45, 90 triangle. Then it also has the coordinates of that next triangle, that 60, 30, 90 triangle we worked on, right? So this is just a reference guide for what we did on that last problem. It just has all the xy values of those triangles. You know, the 45, 45, 90 triangle we did was right down here, right? Look, there it is. And there's the negative root 2 over 2, negative root 2 over 2 we got. So it's a nice visual guide. You should be able to understand what this is giving you, but also be able to make it and come up with these right triangles and these ratios yourself. Okay. So today, not as long of a lesson as Tuesday, but we're on page 501, like I said, and we're looking at the ratios again. Remember we said sine, when we're on the unit circle, the sine ratio is y over 1. That's just because the radius of the unit circle is 1. The cosine is x over 1. And the tangent is y over x, okay? Now, look, if you do a little substitution, right? Y is sine of theta, x is cosine of theta, and those correspond with each other. So I've got another option here for tangent. Instead of saying tangent's y over x, substitute sine of theta for y, I could say tangent is also equal to the sine of theta over the cosine of theta. So this just gives me another option when dealing with sine. Right, so that's another little option. That's still messy. Hold on. Cosine of theta. So it gives me another option when I'm dealing with tangent. Okay, so what this leads us to is an identity. An identity is kind of like a formula that we can use, and this one stems from the quadratic formula. So if you remember, I'm sorry, not from the quadratic formula, from the Pythagorean theorem. If you remember Pythagorean theorem from Geo, it relates the three sides of a right triangle. If this is the x side and this is the y side, the Pythagorean theorem is x squared plus y squared equals 1. Right? Now it's technically, let's go back a step, sorry. The Pythagorean theorem you learned in Geo was a squared plus b squared equals c squared, where c is the hypotenuse. So now if we translate that to the values we're using here, right, that becomes x squared plus y squared equals 1 squared, right? Well, 1 squared, having the square there is kind of pointless. It's just 1. So that's what we get. Now, let's use that same substitution we used back here on the last page. Remember we said sine of theta is equal to y, cosine of theta is equal to x. So what I can do here is replace x with the cosine of theta, and I can replace y with the sine of theta, and that still equals 1. So what this does is this brings us to this relationship called the Pythagorean identity, okay? Now I'm going to clean this up in a second. What's important to note on this page is this notation I have up here. When dealing with these trig functions, there's two ways you can deal with exponents. You can write the exponent like we did right here, right? You can write it with the exponent outside, like around parentheses. That's the probably the form you're most comfortable with. But the one you got to get used to is this here. That is okay. That means the same thing as sine of theta squared. So it's a strange notation. We couldn't do that with logs or anything like that. But with trig functions, we can write it a little bit differently. So I'm going to write this as cosine squared of theta plus sine squared of theta equals 1. And that is my Pythagorean identity. Now that is true for every angle in the world. If you square the cosine value and you square the sine value, it's always going to equal 1. So let's just formally write that over here. The cosine squared, I'm going to, just in the examples here in the book, I'm going to write it as this. In my examples in the answer key, I had the sine squared first. It doesn't matter, right? With addition, you can flip the order. But on my homework answer key, I had sine squared first for everyone, so I don't want to confuse anybody. Okay, so that's Pythagorean theorem. Now let me show you how you can use that. Okay, so here's an example. We have the cosine of theta equaling negative 3 over 5. Now, if you think about this, if you look back at our unit circle here, that is not an x ratio that we know, right? That is nothing on here. None of the x values have negative 3/5. So we can't use the unit circle. We can't make any special right triangles. So we have to do something else. Now, here's what we do know. We know that the theta is between pi over 2 and pi. Okay, so you've got to be good with your radiant angles and know that pi over 2 and pi is somewhere here in quadrant 2. Okay, that's it. So what we're going to do now we don't know what kind of angle that is. We don't know if it's a special right triangle. We don't know anything. All we know is that theta starts on the x-axis and rotates to the second quadrant because it tells us, it tells us here between pi over 2 and pi. Okay, so now I can't do anything else. I don't know the special right triangle. I can't mess around with that. But what I can do is use the Pythagorean identity. So sine squared plus cosine squared. So now I can replace cosine. Remember, first we had it equal 1. At first we had a cosine of theta in there. But because the cosine of theta is equal to negative 3/5, I can just throw the negative 3/5 in there, substitute it out. Now look, you only have one missing variable, theta. Remember, theta is just the Greek letter we use to represent angles in trigonometry. So if I clean this up a little bit, sine squared of theta plus negative 3/5. If I square the top, I get 9. If I square the bottom, I get 25. Right? The negative is irrelevant because I squared it. If I subtract a 9/25 over. I'm going to make 1 into 25 over 25 right away because I know I need common denominators. So then I get sine squared of theta equals up top. Remember, when you got common denominators, the denominator is going to stay the same. You just subtract the bottoms, so you get 16. You just subtract the numerators. So I get positive 16. Now I square root both sides, and I get a sine of theta. Remember, when you square root both sides, you do plus or minus 4/5. Okay. Now the plus or minus is important because remember, on the first example we saw, we reminded ourselves that sine and cosine values can be positive or negative. Okay. Because this angle is in quadrant 2, I know I want it to be a positive sine value. So I'm picking the positive one. So zoom out a little bit. So sine of theta equals positive 4/5. There's my sine. Okay. Now I also have to find tangent. Remember what we said, we have another option for tangent back here. We don't know the xy value at that point, but we do know the sine and cosine value of that angle. So I'm going to find the tangent. I'm going to take the sine ratio, 4/5, divide it by the cosine ratio, negative 3/5, and clean it up. Multiplying by the reciprocal. Right, I'll show you. You can save a step here and kind of multiply by the reciprocal in one step. So multiply by negative 5 over 3. And the 5s are going to reduce. So we're going to get negative 4/3 as our tangent of theta. All right. So there we go. A different way to find the sine, cosine, and tangent ratios if it's not on the unit circle. And remember, negative 3/5, remember we're given the cosine of theta equals negative 3/5, that's nowhere on the unit circle. So we can't use it. We can't make any of our special right triangles. Okay. Go ahead and try this one. Pause the video. Actually, let's do this one together. Let me see. Let's do this one together and I'll let you guys try that one on your own. That's the last two we'll do. Okay, so again, cosine equals negative 8/17. That is not one that is on the unit circle, not a ratio we know. It's not a special right triangle, so I've got to figure out what's going on here. Use a Pythagorean identity. So this one between pi over 2 and pi, again, pi over 2 and pi is in quadrant 1. Quadrant 2, so it's somewhere over here, right? This angle here is theta, all right? So using the same identity, I'm going to use sine squared of theta plus, clean that up, sine squared of theta plus negative 8/17 squared equals 1. So sine squared of theta plus 64 over 17 squared. I should know. I'm going to pop it in my calculator here because I don't want to make any mistakes. I think it's 289. 289 equals 1. So now I'm going to subtract that over. Give them common denominators. 289 over 289 minus 64 over 289. So I get a sine squared value of 225 over 289, right? Now I square root both sides. Sine of theta equals plus or minus 15 over 17, right? So now I have to think about which quadrant theta is in and whether I want the positive or the negative. And kind of like the last one, it's in quadrant 2, so the sine value is positive. So 15 over 17 is my sine ratio. Now, for the tangent, you can try this one on your own. Take the sine ratio, divide it by the cosine ratio. We're going to get a negative, and the 17s are going to cancel out. So you're going to get negative 15 over 8. Negative 15 over 8. And that's the tangent. Okay. So that is another way to find this sine and cosine and tangent ratios. These you do need to be given one, and the other ones with the special right triangles, we just need to be given the angle. What's weird too is we're doing this without ever finding the angle. There is a way to do that, but we're not even worrying about that right now. We're just finding the ratios. Okay, last one, take a quick second. This one's a little different. See if you can figure out which quadrant this is in and use the Pythagorean identity to find the missing values. Okay, so cosine of theta equals negative 5/13, and this guy is between pi and 3 pi over 2. So now we're down here in quadrant 3 somewhere. Don't know where, don't know the angle, but we know the cosine is negative 5/13. So to find the sine, sine squared of theta plus negative 5/13 squared equals 1. Clean that up, sine squared of theta plus 25 over 169 equals 1. Sine squared of theta equals, let's make common denominators. 169 minus 25 over 169. So sine squared equals 144 over 169. Square root, square root. You get a sine value of plus or minus 12/13. Now be careful, plus or minus is essential here. Because I'm down in quadrant 3, that is a negative sine ratio. Remember, just think about the x value, the y value at that point. The x value is negative and so is the y value. So that's why I've got to have the sine being negative 12/13. Right? Now the tangent, take the sine ratio, divide it by the cosine ratio. You're going to get negative 12 over 13 divided by negative 5 over 13. And when you do that, multiply by the reciprocal. A negative over a negative is a positive, so you get positive 12/5. Okay. Now, I just realized that all these practice problems start off giving you the cosine of the ratio. Some in the homework are going to give you the sine to start, but it's the exact same thing. You start off with, so say I gave you the sine of theta equals 2/7 or something, and I told you I'd have to tell you where theta is. We know between pi and maybe 3 pi over 2. Okay, something like that. I have to tell you the quadrant. So if you know this, actually that would have to be a negative sign. So it's the same process. You would just plug in negative 2/7 for sine, and cosine squared of theta would help you find the cosine ratio. So you actually would just solve for the cosine of theta. The 3 examples I didn't realize none of them started with a sine ratio, but it's the exact same technique. So there's one more quick video to watch. It's 33-2 video notes, and then the homework.